Welcome you all for today's session. In today's session, we will be dealing about single parity check, which is one of the method of finding or detecting an error in a given data frame, which is to be sent from sender to receiver. So how does the error occur whenever the data frame is to be sent? The first one is the single bit error. The single bit error occurs whenever there is a change of one bit in a given data frame. First, suppose if we have a data frame in format of 1 byte, let's take an example of 01101001. If there is an error at least significant bit which is changed from 1 to 0. Here only one bit is being changed out of the entire bit values. That we call it as a single bit error. Means what? If there is a change of one bit in a given data frame, that we call it as a single bit error. What is the burst error? The burst error is if there is more than one bit changes, then we call it as a burst error. Now we will deal with how do we detect an error by means of single parity check. So let's consider a data frame. Let's consider a data frame which is in format of 1 byte. So let's take an example like 0, 1, 1, 0, 0, 0, 1 and 1. So how does the single parity bit work? So if this is MSB and if this is LSB, the higher bit value we call it as most significant bit, the lower bit value we call it as least significant bit. On counting the number of ones, if the number of ones is even, so at the position of MSB, if we call it as M as a position, the M plus 1 position will be made as 0. So if this is M plus 1 position, okay, if the number of ones, if the count of number of ones in a given data frame is even, then the M plus 1 position will be made as 0. If number of ones is equal to odd, if the count of number of ones is equal to odd, then M plus 1 will be made as 1. So in our case, if this is the data frame, let's count the number of ones. So the number of ones is ending to, the count is equal to 4, which is even. So when it is even, at the position of M plus 1, we will be adding 0. Okay. So at the sender end, what will happen? Let me write in the box. At the sender end, the count of ones is considered. The counts of ones is considered on the total number of count, on the total count. If even, what we will do, we'll add M plus 1 being equal to 0. Otherwise it will be 1. Right? So this is what happened at the sender end. So what will sender do is, the sender will accept the data frame. It will count the number of ones. If the number of ones is even, it will add 0 at the M plus 1 position. If the number of ones is odd, it will add 1 at the M plus 1 position. So at the receiver, what will happen? So let me take the receiver end. So the receiver will accept this particular data frame. The receiver will accept this particular data frame, which is not only having a data frame, along with data frame, we also have a single parity bit. In my example of data frame, the single parity bit is 0. Okay, so it will accept and it will be approached towards the condition loop. It will be approached towards the condition loop. So what will be the condition? If the parity bit is equal to 0, means what? If the parity bit is made 0, we will say if it is yes, the data frame is acceptable. If the parity bit is made as is 1, then it is not acceptable. Okay, not acceptable. No or yes. If parity bit is equal to 0, it is acceptable. If parity bit is equal to 1, it is not equal to 0, it is not acceptable. Means in this kind of concept of considering parity bit, we will call it as even parity. We will call it as even parity. Means what? If the total number of ones are even in number, then the m plus 1 will be made it as 0. If it is 1, it is the total number of ones are odd in number. Okay. So here in our case, what will happen? As the parity bit is 0, so the data frame will be acceptable. Okay. This is how, by considering the parity bit value, it will say whether the frame that is sent is correct or not. So as the parity bit is 0 in our case, so this particular data frame is correct, so it will be acceptable. Let's take an example. Let's take an example of how does the error that will be detected at the receiver end. So let's take an example like at the sender. So the data frame is something like this: 1001. And all the other values, let me just keep it as 0. Okay, so this is the data frame. So on counting the number of ones, the parity bit will be decided, right? So what will happen? The total number of ones are even. The count is equal to 2, which is even. As we already know, whenever it is even, the parity bit is 0. So the sender will decide the parity bit, that is already done, at the receiver. So what is the data frame? How is the data frame here now? The data frame is having along with the parity bit. This is the parity bit and data frame is also there. That is 0, 1, 0, 1, 0, 0 and 0. The same set of bits will be sent to the channel. Okay, transmission mode or a transmission channel, we can say. Fine. At the receiver, let's say due to some distraction or some error that has occurred, there is a change of the bit. Let's say the single bit error has occurred. What is single bit error? There's a change of 1 bit in the data frame. Let's say the parity bit is same as it is and there is change of 1 bit. So I am changing the MSB bit. The MSB bit is changed to 0. So all others I will keep as it is. It is 0, 0, 0, 1 and all the other values are zeros only, right? Now what will happen? As we already know, this is a parity bit. So now the parity bit, this will be, the receiver will first count the number of ones. The receiver will also count the number of ones. But the count is odd here. The count is odd. So what should be the parity bit? The parity bit should be 1. What is the condition here? The condition here is if parity bit is equal to 0, it's acceptable, right? If it is no, it is not acceptable. Means what? There is some error. There is some error in the data frame. In our case, what will happen? When the receiver will receive this particular data frame, during the transmission of the data frame in the channel, due to some distraction, the MSB bit has changed from 1 to 0. Okay, but still the parity bit is 0 here. So what will receiver will easily know that though there is a change, though the count of 1 is coming to be odd, but the parity bit is 0, supposed to be 1. So what will the receiver will clearly know that there is some error that has occurred in the data frame. So this is how the concept of single parity bit works when we consider it as a even parity. Similarly, we'll go with the odd parity. What will happen in odd parity is, the concept of odd parity is, if number of ones are odd, then the parity bit will be set to 0. If the number of ones are even, then the parity bit will be set to 1. Okay, as different to that of even parity. In even parity, what will happen? If number of ones are even, then parity will be 0. If number of ones are odd, counts are odd, then it will be P of 1, right? Here in odd parity, it is reverse of this. If the number of ones are odd, then it will be P of 0. If number of ones are even, it will be P of 1. So this is how the single parity check will work in knowing the detection of errors. Thank you so much.